10 years, one mineral has stood between China and total control of the American electric car market: lithium. Every EV battery on the American road runs on it. It comes out of the ground in only a handful of countries. It's priced like a commodity, and right now, that price is climbing hard again. It was the last choke point the West could still point to, the last card in the deck. But at the end of this year, that card gets pulled. CATL, the company that already makes close to half of every EV battery in China, starts mass-producing an EV battery that doesn't use a single gram of lithium. No lithium, no cobalt, no nickel. The whole thing runs on sodium, the sixth most common element in the Earth's crust. It's sitting in seawater. It's in your kitchen salt, and there's a car on sale right now, today, with this exact battery inside it. The price? 30% less than the cheapest lithium battery on the market. The lifespan? 15,000 charge cycles, that's 40 years of daily use. The cold weather performance? 90% capacity at minus 40 degrees. By the end of this video, you'll know how much of this to believe. What sodium can do to the market right now, what it still can't. And which American companies just got put on a clock. If you like technology breakdowns that reach the shift between China and the West before the headlines do, hit subscribe. For the last decade, the entire electric car depended on a mineral that comes from only a few places on Earth. Australia, Chile, China, a short list. And that scarcity is the point. When a material is rare and everybody needs it, whoever controls the supply controls the price. Whoever controls the price has leverage over every carmaker on the planet. That was the one piece the West could still point to and say, we have a hand in this. Not the manufacturing, China owns that. Not the processing, China owns most of that too. But the raw lithium, some of it still came from mines the West had a stake in. The last handhold on a cliff face China had spent 20 years climbing. Here's what makes the sodium story strange. Sodium has never been rare. It's in seawater. It's in the salt on your table. Engineers have known it could store energy since the 1970s. So if it's everywhere, and we've known for 50 years, why has there never been a sodium car you could actually buy? Because knowing a thing is possible and building it at the scale of millions of identical cells are two completely different problems. Sodium worked in a laboratory. It fell apart on a production line. That gap between the science and the factory is exactly what CATL says it just closed. And the engineering behind how they closed it is the part worth understanding, because it's also how you tell a real breakthrough from a press release. Every time a Chinese company announces a leap forward, you're left with the same question. Is this real, or is it a marketing department in a lab coat? There's a reliable test. A genuine breakthrough can name the exact thing that was broken and the exact thing that fixed it. So here's the mechanism. A battery works by shuffling ions back and forth between two ends every time you charge and discharge. Lithium ions are small. And for 30 years, every lithium battery has caught them using the same material at one end: graphite. Graphite is built in microscopic layers, and small lithium ions slide neatly between them. Sodium ions do the same job. The trouble is they're physically bigger. Too big to fit between graphite's layers without jamming the structure and wearing it out fast. That single mismatch kept sodium in the lab for 50 years. Everyone knew it could store energy. Nobody could build the receiving end cheap enough and tough enough to hold it at a price a carmaker would accept. CATL's fix: drop graphite and switch to something called hard carbon. Hard carbon has a messier, more open internal structure, room enough for the larger sodium ions to move in and out without destroying it over time. Before I get to the cost side of that fix, one thing. What this channel does every week is take a single Chinese technology claim and run the same test. What holds up, what's marketing, and whose business it quietly threatens. Subscribe and the next one finds you automatically. Now the cost. Hard carbon used to be expensive, around $10,000 a ton 2 years ago. CATL and its suppliers have driven that toward $5,500 a ton by the end of this year. They've roughly halved the price of the key ingredient in 24 months. That's the difference between a clever idea and something you can put in a million cars. The cost headline is 30% cheaper than lithium iron phosphate, already the cheapest chemistry on the market, already the one that made affordable EVs possible. The battery is usually the single most expensive component in an electric car, often a third of the sticker price. Knock 30% off that and you don't trim the edges. You move the whole car into a lower price bracket. Longevity, 15,000 charge cycles. If you fully cycled the battery every single day, that's more than 40 years before it wore out. Most people will scrap the car long before the battery gives up. For grid storage, where a pack might cycle once a day for decades, that number alone makes sodium worth serious attention. Cold performance, 90% capacity retained at -40 degrees. Lithium batteries degrade badly in the cold. Range collapses. Charging slows. Ask anyone who's owned an EV through a real northern winter. The sodium cell barely registers the same temperature drop. That reopens every cold climate market that quietly wrote EVs off years ago: the northern United States, Canada, Scandinavia, northern China. Now the honest weakness, because it's a real one. Energy density. How much power you can pack into each kilogram. A CATL sodium cell currently stores around 175 watt-hours per kilogram. Good lithium iron phosphate is past 250. In plain terms, a sodium battery is heavier and bulkier for the same range. Which is why, today, it makes sense in smaller, cheaper cars and in grid storage where weight barely counts. It does not yet make sense in a long-range premium EV where every kilogram is contested. CATL talks about a 600-kilometer sodium car eventually. Eventually is doing real work in that sentence. The fair objection by now: every month there's a headline about a Chinese lab breaking a record that never becomes a product. What makes this one different? It already left the lab, and you can track it on a calendar. February this year, the first mass-produced sodium passenger car went on sale in China. The Chang'an Nevo A06, built with CATL cells. Not a prototype under a spotlight. A car with a price and a showroom floor. Second quarter, a sodium version of the Aeon UT enters production. September, first batches of sodium grid storage systems delivered to real customers. Fourth quarter, full mass production begins, with cost projected to reach parity with lithium iron phosphate. That's a rollout already half complete, each stage arriving roughly when they said it would. And the company doing it isn't a startup with a funding round to raise. CATL holds 46.6% of China's EV battery market. In April alone, they installed more than 29 gigawatt-hours of batteries, enough in a single month to power millions of cars. When an operation that size commits a factory line to a new chemistry, it isn't testing the water. The decision is already made. Now, not one of those cars is on an American road yet. Tariffs see to that. Hold on to that thought, because it's the exact reason the next part matters far more than it looks. A shift like this doesn't stay inside engineering journals. It reprices companies. And the American names are first in line. Start with the car makers you actually know: GM, Ford, Stellantis, the group behind Jeep, Dodge, and Chrysler. Their entire affordable EV strategy is costed on lithium. Every price target, every margin projection, built on what a lithium battery costs. Drop a battery 30% cheaper into the world market, mass-produced by a company they can't buy from at scale, and the maths under those plans stops working. And here's the uncomfortable part. The tariff wall protects the American market. It does not protect American companies. Ford and GM don't just sell at home. They compete in a global market where the cost floor just dropped through the floorboards. A tariff is a policy, not a moat. It holds until the administration that put it there decides it doesn't. Detroit is being kept alive by a line in a trade document, and they know it. Then the one American miner with the most to lose, Albemarle. Its whole value rests on a single assumption that the world will need ever more lithium and can't get enough. A cheap battery that skips lithium entirely doesn't kill that demand overnight. But it puts a ceiling on the story. The scarcity that made lithium valuable is exactly what sodium is built to route around. And the blast radius runs well past America. SQM in Chile, Pilbara in Australia, the miners feeding the same global market. Panasonic in Japan, Samsung SDI and LG in Korea. Every one of them built their factories and their patents around lithium chemistry, and not one has sodium anywhere near CATL's scale. That's the real shift. For a decade, the West held one card in the EV supply chain: the raw material. Sodium takes that card off the table, and what's left standing between China and the American car market isn't a better battery or a cheaper one. It's a tariff. That's a very different kind of safety than the one Detroit is used to. Before you close this, convinced the lithium age ends this Christmas, 3 things worth sitting with, because the point of a channel like this is not handing you the hype from either direction. First, the energy density ceiling is real and it isn't moving this year. Until sodium closes the gap on watt-hours per kilogram, it's locked out of the long-range premium end of the market, where the largest margins live. Sodium is winning the cheap end. The expensive end still belongs to lithium. Second, the 600-kilometer sodium car that gets quoted in headlines depends on a supply chain that doesn't fully exist yet. Cathode suppliers, anode suppliers, all of them have to scale in parallel over years before that figure is more than a number on a slide. Third, and this is the one almost nobody says clearly, The cost parity claim for the end of 2026 comes from the people building sodium batteries. They have every commercial reason to say it early. It may prove exactly right, but it's a forecast from an interested party, not an independently verified number. File it as a direction, not a confirmed fact, so here's where it actually leaves you. Sodium doesn't have to beat lithium everywhere to matter. It only has to win the bottom of the market, the cheap cars, the city runabouts, the grid storage, and it's already doing that today. In cars you can go and buy. The scarce mineral that gave the West its last point of leverage is being designed out of the fastest-growing, most price-sensitive slice of the market. Whether every headline number survives independent testing is still open. The direction of travel is not. And you're looking at the mechanism now, while it still counts as early. We just watched China take away the West's cost advantage in batteries. But cost was only ever one of the two arguments holding EVs back. The other was time, the 20 to 40 minutes standing at a charger while a petrol car fills in 90 seconds. A few months before this sodium announcement, a different Chinese company put a car on stage that charges from almost empty to almost full in 9 minutes and holds that speed at -30 degrees. Every American automaker has had months to respond. Not one of them has said a word. I broke down exactly what BYD built, why it breaks a 30-year rule of battery engineering that was supposed to be permanent, and why the silence out of Detroit tells you more than any counter-announcement could. That's the other half of how China is rewriting the car, and it's the next video.